Okay, before we start looking at how we differentiate an exponential function, we first need to look at what an exponential function is. It's a function where the rate at which it grows is proportional to its actual value. So if we look at this function here, I move the graph and the tangent to the point on the graph around, we can see at the point that we choose, the value of the function is the same as the gradient of the function. Okay, so here we've got something which the value at which it changes. Remember, the change is the derivative. So the change of a function is that function derived. So the value of the function is proportional to the derivative of that function. And to begin with, that proportion is just 1. So if we take the exponential function, what we're saying is that the function is e to the x. And if we derive that function, the rate at which it changes is also e to the x. So this leaves us with probably the easiest differential rule that there is, that it doesn't change. So to solve this equation, if you've got the function e to the x, the answer is the derivative is e to the x. We're done. Right, ever so slightly trickier. Our new function is e to the 2x. Well, the answer is it's still proportional. It is e to the 2x all times by 2. So where does this come from? So here's my function. Got function is e to the 2x. But that 2x part is in function inside it. So we've got a composite function. We're going to have to use the chain rule. So the inner function g is 2x. So dg dx is 2. The outer function of g, f of g, is e to the g. So if we differentiate f with respect to g, we get e to the g. And we just have to impose our chain rule now. F of x is df dg times dg dx. So we've got e to the g times 2. And if we just rearrange this, and don't forget to substitute back in 2x for g, and now we're done. Right, you can see when we've got composite functions, this e to the x differentiates to e to the x rule, makes things very easy. The original e to the something doesn't change, and you just multiply by the derivative of the inner function. So still a simple chain rule. And a product rule, once again, stays very simple. We've got dy dx is equal to f prime g plus g prime f. So f is e to the x, so that's not going to differentiate to anything different. And g is sine of x. So here's the chain rule. F is e to the x, so f prime is e to the x. It doesn't change. G is sine of x, and we know that the derivative of sine is cos, so that's cos of x. So we've got f prime e to the x times sine x plus cos x times e to the x again. And because we've got the same term twice, we may as well simplify it by factoring it out. And that's that. Easiest rule.